This is section 2.6. In this chapter, section of the chapter, we will be talking about the meaning of an exponent and the difference between having the opposite of a number raised to a power and a negative number raised to a power. Then we'll talk about order of operations and we'll revisit translation problems. So first of all, a little bit of definitions here. Let's recall that an exponent represents repeated multiplication. The big number, that's the little number above and to the right of the bigger number. The bigger number is called our base. That number can be any real number, and it is the number that is being repeatedly multiplied, the number being used as a factor. When we have an exponent of 2, we call that squared, and when we have an exponent of a 3, we call that cubing, and any other number, we just say raised to the power of, or to the power of, or raised to the, or just to the, and 2 and 3 can be said in the exact same way. So let's do some practice problems. Example 48, we're going to be raising 3 to the 4th power. So the first thing that we want to do here is we want to expand that. So this means 3 times 3 times 3 times 3, and then we'll just go about the multiplication. So 3 times 3 we know is 9, and 3 times 3 we know is 9, and then 9 times 9 is 81. So 3 to the 4th power gives us 81. Base can be a fraction as well. So this says 1/4 raised to the 2nd power. So that means 1/4 is being used as a factor 2 times. 1/4 times 1/4. And when we have 1/4 times 1/4, we're going to multiply the numerators. 1 times 1 is 1. 4 times 4 is 16. So 1/4 squared is 1/16. You do want to leave those as fractions. Fractions remain as fractions. Decimals remain as decimals, please. 0.05 cubed. We have 0.05 times 0.05 times 0.05. So let me get that written out as our expansion. And then we're going to multiply. And when we multiply decimals, remember, you want to ignore the decimals for a moment. 5 times 5 is 25, and 25 times 5 is 125. And then we want to count up the number of decimal places. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, and 6. So our decimal is going to go right there. And once we get the decimal in, I'm going to put an extra 0 out there so that that decimal doesn't ever get lost. And there will be our final answer. Our final one down here, we have a negative number being squared. So that means the negative number 3 is being used as a factor 2 times. A negative times a negative is a positive, and 3 times 3 is 9. So this is a positive 9. Now we want to make sure that we know the difference between a negative number being raised to a power and the opposite of a number to the power. They don't necessarily mean the same thing. This opposite of 2 squared does not equal a negative 2 squared. So the left side, the opposite of 2 squared, looks like this. The opposite out here, and then 2 times 2. And the right side looks like the negative 2 times the negative 2. So you see negative 4 doesn't equal positive 4. So we're going to look at example 49 here to see more of that. So our first part in 49 says negative 5 squared, whereas the second part says the opposite of 5 squared. So in part A, what we have here is a negative 5 times a negative 5. And a negative times a negative is a positive, and 5 times 5 is 25. So that's our answer in that one. Now this one says the opposite of 5 squared, which is the opposite of 5 times 5. And that is going to give us a negative 25. And then finally, our last one here, example 50, just practicing each of these. So you might want to pause here and then come back and get the answers in just a moment. So this one is a negative 3 times a negative 3, which we already saw. Negative 3 times a negative 3, and that's going to give us a positive 9. And then this one says the opposite of 3 times 3, and that's going to give us a negative 9. And then finally, this one says the opposite of a 0.25 times a 0.25, and 25 times 25 is going to give us 625, and then we'll need 4 decimals, so it'll be a negative 0.0625. And I might not get that written.